Hi everyone, today we're going to study Properties of Real Numbers Part 1. We are going to start with the operation of addition as denoted by this plus sign. The first property is what we call closure property. The closure property says the sum of two real numbers is a real number. As an example, we're going to pick two real numbers, 2 and 3. And if we're going to add these two numbers, such as 2 plus 3, the answer will be 5. And this 5 is also part of a real number. That is property number 1, closure property. The second property under addition is what we call commutative property. In here, two real numbers can be added in either order. Numbers are here represented by A and B. So we have here A plus B is equal to B plus A. In other words, the order of the numbers to be added, or we call them addends, the order of addends will not affect the sum. We have here three examples. The first one is 3 plus 5 equals the answer for 5 plus 3. And both will have 8. Another example, 5 plus 7 equals 7 plus 5. Are grouped together, and on the other side still the C will come first and the group A plus B will be on the last. So this idea here still falls under the idea of commutative property under addition. The next property under addition is what we call associative property. The rule says when three real numbers are added, it makes no difference which two are added first. In here we have three letters that represent numbers. In the left side we have A plus the group of B plus C, and that will be equal to, if we group the A plus B first, then later we will add to the C plus C. So we have examples here for number 1, the numbers 5, 6, 7. On the left side we have the 6 plus and 7 grouped together. After that, we can add the sum of 6 and 7 to the 5. The answer will just be same if we're going to add the 5 and 6 first. After getting the sum here, we can add to the 7. Another example is for number 2. In here, 3, 6, and 9 are given. On the left side, again the 6 and 9, the last two terms are grouped together. And on the right side, the first two terms are grouped together. Then later on, if we're going to get the sum of these three numbers, after that, get the sum of the right side, eventually we will get the sum of 18 for the two sides. So on the third example, there are three letters here, and these three letters represent numbers. So PQR is here. In the left side, we have and as the associative property says, whether we add the last two numbers or we add the first two numbers, we will have the same answer. The number 4 property is what we call additive identity. It says here, the sum of 0 and a real number equals the number itself. That is, a plus 0 is the same with 0 plus a, and the answer will be a. In other words, any number added to 0 will result to the number itself, and that 0 is what we call the additive identity. We have three examples here. The first one is 3 plus 0 equals 3. Second example, 0 plus 5 equals 5. Third example, the fraction 2 over 3 plus 0 equals 2 over 3. Again, the number 0 is the additive identity. Number 5 is additive inverse. It says here the sum of a real number and its opposite is 0. That is, a plus the negative a equals 0, and here the minus a or the negative a is the additive inverse of a. We have two examples. 6 plus a negative 6 equals 0. Here, negative 6 is the additive inverse of 6. Example 2, the given is negative 3 plus a positive 3 is equal to 0. Here, the positive 3 is the additive inverse of minus 3 or negative 3. By the way, this additive inverse is related to the identity 0, because it says here, if there is a given number a, we are thinking of another number that if we add to that number a would result to the identity element, and that is 0. In that case, the negative a is the additive inverse of a. Let's go now to multiplication properties, and this is denoted by a dot. The first one is closure property. The closure property says the product of two real numbers is a real number. It means if we are going to multiply two real numbers, the answer can be found also in the group, inside that group, the group of real numbers. Let's have this first example. 2.3 or 2 times 3 equals 6. And this number 6 is a real number. Another example, 2 times negative 3. The answer is negative 6. Again, this negative 6 is a real number. Third example, 4 times 3. These are real numbers that are being multiplied, and the answer is 12, and this 12 is a real number itself. Next property under multiplication is this commutative property. It says two real numbers can be multiplied in either order, that is, A times B equals B times A, where A and B are real numbers. In other words, if we're going to interchange the position of the factors, the product will be same. Let's see the example number 1. 3 times 5 will be equal to 5 times 3, and both of them will be equal to 15. Example 2, 5 times 7 is the same with 7 times 5. In example 3, we have three letters here. This is A plus B taken as one group multiplied by C. So since A plus B is taken as one group, we can do the commutative property, putting this A plus B on the right side, and the C will come first. C times the group of A plus B. And this A, B, and C are all real numbers. The third property under multiplication is associative property. It says when there are three real numbers to be multiplied, it makes no difference which two are multiplied first. Showing by equation, this is A multiplied by the group of B times C will be equal to the product of A times B first. After taking the product, we multiply to the C, where A, B, and C are all real numbers. So we have three examples here. In the first example, 5, 6, and 7 numbers are involved. On the left side, we have this 6 times 7 grouped together. After that, we will multiply the answer to the number 5. The answer will be the same even if we group the 5 and 6 first, taking the product here. After that, the product will be multiplied to the number 7. At the end, these two sides will have same answer. Next example is number 2 example. 3 times the group of 6 times 9. This is equal to the group of 3 times 6. Afterwards, we multiply to the 9. The third example is there are letters that represent numbers. Here we have P, Q, R. On the left side, the Q and R are grouped together and then multiplied by P. This is equal to the group of P times Q. Then later we multiply the product to R. So this is associative property. In other words, the grouping of the factors will not affect the product. The fourth property under multiplication is what we call multiplicative identity. It says the product of 1 and a real number equals the number itself. That is, A times 1 is equal to 1 times A is equal to A. Example number 1, 3 times 1 will be same with 1 times 3, and the answer will be 3. Example 2, 1 times 5 equals 5. Example 3, 2 over 3 times 1 equals 2 over 3, or 2/3. So that number 1 is called the multiplicative identity. In other words, any number multiplied by 1 would result to the number itself. The fifth property under multiplication is what we call multiplicative inverse. It says the product of a non-zero real number and its reciprocal is 1. Again, this number 1 is the multiplicative identity. And that is, if we have this A multiplied by 1 over A is equal to 1. And here, the 1 over A is the multiplicative inverse of A. We have two examples here. Example 1, 6 multiplied by 1 over 6 equals 1. Here, the 1 over 6 is the multiplicative inverse of 6. So we are taking the reciprocal of the given number. Example number 2, the given is a fraction, 1 over 3. So we think of a number that will be multiplied to this 1 over 3 to make the result to be 1, the identity. And that number is actually the reciprocal of 1 over 3, and that is this whole number 3. And this 3 is called the multiplicative inverse of 1 over 3. Hi everyone, today we're going to study properties of real numbers part 2. Let us begin with distributive property of multiplication over addition. Let us consider 3 letters representing real numbers A, B, C. So here, the A is multiplied to the group of B plus C. So this A is distributed to the B and to the C. And this is A times B plus A times C. As an example, the number 2 is to be multiplied to the group of 3 plus 4. And this is equal to the 2 times 3 plus the 2 times 4. Another example is this number 3 is multiplied to x plus y. And this is equal to 3x plus 3y. The next property is about properties of negatives. So we let A and B be any two real numbers. Then the first rule is negative of negative A equals A. In other words, the negative of a negative number is positive. As an example, the negative of negative 5 equals positive 5. The second rule is about this negative A multiplied by negative B equals positive AB. In other words, if we're going to multiply two negative numbers, the answer will be positive. One example here is negative 5 multiplied by negative 3 equals positive 15. The third one is when we're to multiply two numbers of opposite sign, one is negative, the other is positive. As you see here, this is negative A multiplied by positive B. On this rightmost part, this A is multiplied to negative B. So they have different signs. And the answer for both cases will be a negative AB. So we're going to multiply the numbers as it is, and the sign, we will affix the negative sign. So one example here is negative 5 multiplied by positive 3. The answer is negative 15. The fourth one is this negative 1 multiplied by A equals negative A. So in this case, we can remove the number 1 here, and it is understood that the coefficient of this A is 1 or negative 1. One example here, negative 1 multiplied by 7 equals negative 7. The fifth rule is when we are going to divide two numbers of opposite signs. So one is minus or one is negative, the other is positive. See here, negative A divided by B. In this right part, it is A divided by negative B. In both cases, the answer will be negative A over B. In other words, if we're going to divide numbers of opposite signs, the answer will always be negative. Of course, there is a restriction that the denominator must not be equal to 0. One example here is negative 10 divided by 5. This is the same with 10 divided by negative 5. And both will have an answer of negative 2. The last rule is when we're going to divide two negative numbers. In this case, we have negative A divided by negative B. The answer here is positive A over B. There are some cases that looks like this. There is a big negative sign here outside, and then there is a division of two numbers of opposite sign. In this case, this is negative A over B, and on the other case, the B is the negative, the A is positive. Because of this negative sign outside, and if we're going to simplify this, we are going to have a negative sign. It's like we have a negative of a negative fraction, and the answer will be positive. Again, the restriction is the denominator must not be equal to 0. One example here is negative 10 divided by negative 5. Or this is the same with the negative of the fraction negative 10 over 5, which is the same with the negative of the fraction 10 over negative 5. And for these three problems, the answer is positive 2. We go now to the zero properties. Let's have this A and B representing any two real numbers. Then the first zero property is A multiplied by 0 equals 0. It's like this 0 is a powerful number that when you multiply it to any number, it will consume the other number, and the answer will just be 0. One example is 2 times 0 equals 0. Another example is this group x cubed plus 1 multiplied by 0 equals 0. So even though there is a big group here, if we multiply it by 0, the answer will be 0. The second property for 0 is when we have this a times b equals 0. This statement will be true if and only if a is equal to 0 or b equals 0 or both are zeros. One example here is 3 times b equals 0. This will be true if the b equals 0. Another example is p times q equals 0. This will be true if the p equals 0 or maybe q equals 0 or both are zeros.
Let us have more sample problems. Problem 1. Use the commutative property to rewrite the expressions. We have here two expressions. We know that commutative property says the order of the numbers will get same results. For expression in a, y plus 1. So this is equal to 1 plus y. For expression in b, negative 2a. So this is multiplication. The first number is negative 2. The second number is represented by a. So using commutative property, we will write a comes first times the negative 2. Problem 2. Use the associative property to rewrite the expressions. We know that associative property says the groupings of the numbers will get same results. Let us see expression A. We have here 3 numbers. The first 2 are grouped together, and the third one is outside. So now, using associative, this is equal to 11 plus, we now group the last 2 numbers. Now 9 plus 14. For expression B, we have here 3 numbers multiplied together, but the first 2 numbers are grouped together. 12 times 5 are grouped together, then times 7. By associative, we will write like this: 12 times the group, 5 times 7. Problem 3. Simplify the expression using the commutative and associative properties. The expression is negative 45a plus 15 plus 45a. Let us now begin. We can interchange this 15 and 45a. So it becomes like this, for the reason of commutative property. And from here, we can group together the first and the second number. So it becomes like this, for the reason of associative. And then let us simplify this negative 45a plus 45a. This becomes 0, and then plus 15. And 0 plus 15 equals 15. This is the answer. Problem 4. Simplify the expressions using distributive property. Let's begin with expression A, 4 times the quantity x plus 8. By distributive property, we're going to multiply this 4 to x, and then plus, we multiply 4 by 8, just like this. Then we combine together. 4 times x is 4x, and then plus 4 times 8 is 32. For expression B, negative of the quantity r plus 7. It seems like we have a negative 1 here to be multiplied to the terms inside. So finally we can write negative r minus 7. This is the answer. Problem 5. Identify the property used in the expression 101 plus 0 equals 101. We can see here that 0 is added to 101 and the sum is same number 101. Note that 0 is the identity number for addition. So for this, the answer is we use the property identity property for addition. Problem 6. Find the additive and multiplicative inverse of 8. Let's begin with additive inverse. For this additive inverse, we will simply change the sign of the number. So this is 8, or we can say positive 8. That means for the additive inverse, it is negative 8. For multiplicative inverse, we are going to take the reciprocal of the number 8. For this 8 as a whole number, there is a denominator of 1. So that means for this multiplicative inverse, it is equal to 1 over 8. Problem 7. Simplify using the properties of 0. Expression A, 0 divided by 11 over 12. Remember that 0 divided by any number, in this case a fraction, equals 0. That means this is equal to 0. Expression B, 3 over 0, or we say 3 divided by 0. In a fraction, denominator cannot be equal to 0. There is a rule that division by 0 is not allowed. So that means for this, the answer is undefined.